Okay, so the idea of the data generator is it allows students to do experiments virtually, results which are pretty realistic. So students can create sets of tubes containing chemicals. So here I've got tubes containing enzymes, ethanol, chemicals that are going to develop a colour when those things are mixed. The reactions can take place in all sorts of vessels, tubes, but most of the time students will be mixing the chemicals together in. And a particular use of this is often in assignments. And one very important assignment, students determine the concentration of ethanol in some samples of blood that have been provided by drivers that have been accused of being over the limit. So an example of the way that things work, tubes can be opened by clicking on their lids. Samples can be taken from the tubes by using pipettes, and there are lots of different types of pipette, and these solutions can be taken up from one tube and placed into another. And this is going to be subject to the sorts of errors that will happen in a real lab. So there'll be things like inaccuracy of the pipetting, carryover of the solutions if you don't use a new tip, and all sorts of real life mimicking complications that lead to randomness in laboratory work. So we can mix the samples that have been obtained from the drivers. Again, you see the tube opening there, and let's put 5 microliters of each of these samples into some of the wells. Now, one nice little touch here, you can see that when we mix things together, or when we put solutions together that don't have the same concentration, a little warning by way of this pink outline happens. And we can select the plate, choose mix, and that will make the wells mix again. Let's put a bit of standard ethanol into a couple of the wells. So I'll put that into there, let's put 10 microliters of ethanol into another well, and let's mix those. And then let's actually get a reaction to go by putting 20 microliters of enzyme into all of the wells. So as soon as the enzyme hits the wells, all the ethanol that's in the wells will be converted into a red colour, basically using the equations of enzyme kinetics and chemical interaction. So it'll depend on things like temperature and the concentration of all the components. But the key thing is that it will be doing things completely and utterly with respect to the laws of chemistry. So let's mix all of that and choose mix on here. And if we increase the speed of the simulation, then we'll start to see some colour develop in those wells. Now, even without measuring any numbers at this stage, we can see very clearly that the 5 and 10 microliters that we put in these 2 wells here have produced a colour, and there's colour from these 3 drivers here. There's no colour from driver J. So even without getting any numbers, we can probably surmise that driver J hasn't drunk any alcohol that evening, but driver B is looking pretty bad, and drivers F and D, well, they've clearly had something. Now, to get a proper estimate of what those colours actually mean in terms of the amount of product that's been performed, we can select the plate and actually measure an absorbance. Actually get some numbers from there, and the students can then actually do some calculations. Now, I've shown you here an example with just tubes and a colour being produced, but lots of different outcomes are possible. So we can have bacteria growing in plates, we can have cells being incubated with hormones, we can have all sorts of different readouts. Anything that obeys the rules of chemistry and biochemistry can be modelled to produce readouts that students can do something with.